Alrighty, welcome back to Transition Matrices. This is part 2, building upon the previous video. Um, so, last time we spoke, we looked at new state matrices, and we saw that you could have state n being equal to the transition matrix to the power of n multiplied by the initial state matrix. Now, the cool thing about this is we can build upon that particular functionality to introduce what's called culling and restocking. And the way it works is if you think about an organization that's getting stock in, it's getting added on. That is restocking. If you are getting rid of things, it's culling, which is the same as subtracting. So whether you are restocking or culling, you are either going to be adding or subtracting a matrix to our original new state matrix. And so what will happen is you'll get a recursion relationship where you have the state n plus 1 matrix, so the next state matrix is going to be equal to the transition matrix multiplied by state matrix n plus b. Now this adding on here will be a matrix. It's usually a column matrix, and that's going to be what represents either the culling or restocking. So this matrix on the end here, matrix B, will be able to determine that. Alrighty, so here we are looking at another example. We've got, oh cool, it's Better Health. Better Health Centres run concurrent lift and cycle fitness classes. Perfect. That's happening at all 3 of their gyms in FitTown. It says here, a study shows that 80% of the clients who attend a lift class one week will attend the lift class next week, while the other 20% will move to the cycle class the next week. Cool. So similarly, 70% of the clients who attended a cycle class one week will attend the cycle class the next week, while the other 30% will move to the lift class the next week. The numbers are also affected by people joining and leaving the gyms, with 2 additional people joining the lift classes each week and 3 additional people joining the cycle classes each week. It gives us some additional information also. It says in the first week there were 55 people that attended the lift classes and 62 people that attended the cycle classes. So that's really like the initial matrix there of that in week 1. So it's saying here, can you please set up a matrix recursion relationship that would be used and find out how many people attended the lift and cycle classes in week number 2. Alrighty, so let's start off by creating the matrix of the transition matrix between lift and cycle classes. So again, really carefully working through this information. 80% of the clients who attended lift classes one week attend the lift classes next week. So if they attended lift classes, they're going to attend lift classes next week. That's where the 0.8 or 80% come from. While, as we said, the other 20% are going to go start at lift and go to cycle. Further on, it says 70% of the people who attended the cycle class will attend the cycle class the next week. Cycle and attend the cycle the next week is 70%, and it also gives us the information that 30% would do the lift class in the second week. Next, we're going to create the actual matrix, column matrix that will represent the culling and restocking. And yeah, I know we're dealing with people here, but ultimately that is going to be either adding or subtracting depending on whether they're coming into a class or leaving a class. So that matrix is going to be as follows. So remember, we've got the lift row first and then we've got the cycle class second. So it says that 2 additional people will join the lift class each week. So 2 goes in here, and an additional 3 people are joining the cycle class each week. So they're positive numbers because they're going to be added on. They're joining those classes. We're also going to set up the initial state. For the sake of this, we're just going to call it in week 1. So state 1. And in this particular case, this is how many people were in both the lift and cycle classes. So the first one is the lift classes. There were 55 people in the lift class, and in the first week there were 62 people in the cycle class. So we've got all of our information there now ready to work out what's happening in the second week. So again, the rule to work this out is up here. If we're working out what's happening in week 2, it's going to be state 2. It's equal to the transition matrix, which is this one over here, multiplied by the state before this one, which would be S1, plus the culling or restocking sort of matrix here, so plus B. So let's put those down. Transition matrix is as follows: 0.8, 0.2, 0.3, 0.7, multiplied by the initial week, and then we're adding on that culling and restocking matrix. So this particular case isn't asking us to go any further, but it's showing that this is the matrix that we could use to find out how many people attend the lift and cycle classes in week number 2. So if you did multiply these two matrices and add this on, obviously then you'd be able to get who or how many people are going to be at lift and how many people are going to be at cycle. Alrighty, the next thing we want to talk about is what's called a steady state. So it says here, as we get higher and higher powers of the transition matrix, we find that the values of the elements in the transition matrix show no noticeable difference, and they often approach a fixed matrix the more you get closer to infinity, that power of as we get to such a large number. So when you get to that particular state, the steady state or transition matrix to the power of infinity, that can also be known as a long-term transition matrix. Now, if you are asked to test for a steady state, what you need to do is find where that matrix values start to stay the same. And so for the sake of this particular exercise, probably choosing a value of 50 would be a suitable value of n. So transition matrix to the power of 50 would be good. And so what you would do is you would choose transition matrix to the power of 50, then you would test the one after that. So in this case, transition matrix to the power of 51. And what you would hope to see, if they are going to be a steady state, is that the elements in the matrix haven't changed. Again, it says here, note, if t to the power of 2 contains any zeros, then it is not possible to reach a steady state. Okay, so that's a good one to make a note of. If they ask you, is it possible to get to a steady state? If in t to the power of 2 there are zeros, you are not going to be able to get to a steady state. So there's no point, or you can answer that question really quickly there. So as you can see here, we've got a transition matrix to the power of 2, to the power of 3, and so forth. When you get to, and we can test it out here, that transition matrix to the power of 50, and you can see here we've got some fractions, or that'd be some quite long decimal values. When we check transition matrix 50 compared to 51, you'll notice there's no change between these. So in this particular case, because there is no change between these values, it has gotten to a steady state. Perfect. Alrighty, last example for this video. Oh, cool. It's an insurance company question. Now it says here, the insurance company needs to measure its risk to underwrite a policy for a major event that's planned. Cool. The company used the following information about the region. It says here, the weather for the next day for a region in Victoria from long-running data suggests that there is a 75% chance that if today is dry, that the next day will also be dry. So again, starting to put this into a table. If today is dry, the next day is going to be dry, 75%. It says, on the other hand, if today is wet, there is a 72% chance that the next day will also be wet. So if the day is wet, 72% chance that the next day is going to be wet. Obviously, we know that we can get these other values that were unknown, not in here, because each of these columns adds to 1. Alrighty, the question goes on and asks us to find the probability that it will rain in 3 days' time if the initial day is dry. So, first thing we need to do is put this information to a transition matrix. So really simply, putting it in. Again, this was dry, this was wet, dry, wet. That was 0.75, that was 0.25, that was 0.28, that was 0.72. As an actual transition matrix, 0.75, and 0.72. Excellent. The next thing we're going to make a note of is the initial matrix. So if we have the initial matrix, we're going to have it, what we're going to use is we're going to use a 1 to represent it being dry and 0 to represent it being wet. Okay, so in the first on the first state, it was saying in the question, we're going to find out if the it was initially, find out what's happening in 3 days time if it was initially dry. So again, dry is at the top here and wet is down the bottom. So because it was dry to start with, we'll put a 1 there, and it's not wet. Okay. If it was wet in the first day, in the initial matrix here, you would have a 0 in the dry position, which is the top one, and a 1 in the bottom one there, where it's wet, to say it was wet. Alrighty, the question was saying, hey, what is happening in 3 days' time? So in 3 days' time, you're finding state 3. So that is equal to the transition matrix to the power of 3 multiplied by the initial state. So let's run that calculation. That's to the power of 3 multiplied by the initial state. Initially, the first day is dry. So the first one is dry. That's why I've got a 1 there. It's not wet. That's why I've got a 0 there. Running this calculation, you get the following: 0.577275 and 0.422725. So, alrighty, now that we've run these calculations, it says find the probability that it will rain in 3 days' time if it was initially dry. So you can see rain is the second one, so wet with the second value, it's going to be 42.2%. So let's write that out. The probability of a wet day, so it's raining in 3 days' time, is 42.2%. Alrighty, the next part of the question is asking us to find the long-term probability of rain if initially the day is wet. So again, when they're talking about long-term probability, they're talking about seeing if it gets to a steady state, where we can work that off into the future. So again, steady state, what we're going to be doing is looking really for S50. And so what we'll have to do for that is find the transition matrix to the power of 50 multiplied by the initial state. In this particular case, it was saying the initial day is wet. So for the initial matrix, remember it's dry is the top one, wet will be the second one. So because they're saying the initial day is going to be wet, there's a 1 down the bottom for wet and a 0 for dry up the top there. So let's do this now. So you're going to have S50 is equal to t to the power of 50 times S0. Our transition matrix was from above, 0.75, 0.25, 0.28, 0.72. That's the power of 50. And that is going to be multiplied by the initial state where it was wet on the first day. So the ones there. Okay, so what you would do, you'd run that and you'd get the following. 0.528302 and 0.471698. Cool, so here are the percentages here. To check long-term probability and see that it is a steady state, you would do the same thing again with S51. So you do transition matrix to the power of 51 multiplied by the initial state. You could run that calculation, but it is the same as that there. So it is a steady state. So what you would say here, in this particular case, is in the long run, there is a 47.2% chance it will be wet. Be a wet day if the initial day was wet also. Cool. All right. Last but not least, I know it's a bit hard to read, but we'll plow through. It says if the company only insures if they have the odds in their favour, will they insure this particular event? So what we need to be looking at here is the long-term probability, and really for an event, a major event that's happening outside, they're only looking at insuring it if the chances of it going ahead are dry conditions. That is, it's not going to rain, it's not going to be rained out. So what they're looking for, is in the long term that the chances of it being dry are greater than it being wet. And so what you can see here from our long-term calculations with the steady state, there was 52.8% chance of it being dry in the long run and 47.2% of it being wet in the long run. So when we talk about whether the insurance company's got the odds in their favors or in their favor, it's more likely to be dry than it is to be wet. So it is in their favor. So they would insure it in this particular case. So actually writing that in a nice fun sentence, I would say in the long run, there is a 52.8% chance it will be a dry day. The odds are slightly in favour of the insurance company. Therefore, they will insure the event. Perfect. All right, thank you very much for listening up. I hope you've enjoyed Transition Matrices Part 2. Bye for now.